Hi kids, it's Mr. Comans. I'm going to do a little video for you today on probability using playing cards before we do our next Zoom lesson. So I had some playing cards delivered from Amazon and they came in this packet here. So I've got some Royal high quality playing cards. Now before we do the probability questions, you need to know what's in a pack of playing cards, which is used for all different games. So there's 52 cards plus 2 jokers. We're not going to use the jokers when we do the probability, but this is what the jokers look like. So I'm going to put those away and we're not using those. So you have 52 cards then. And the cards come in 4 suits. Now, 2 of the suits are black and 2 of the suits are red. Okay, these ones are the spades. That little picture there, that little symbol, that's called the spades. And as you can see, I'll just turn them around. They go from ace, and ace is like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then after 10, you don't have 11, 12, and 13. You have Jack, Queen, and King, and these are called the picture cards sometimes. And in most card games, these are the best cards. They're the highest cards because they go above the 10. Okay, so sometimes these ones here are called the picture cards, and the ones with the numbers on them, okay, which go from 2 to 10, they're just called the number cards sometimes. Now in some card games, the ace is a 1 and it goes like below the 2, or sometimes the ace is also the highest card, so it can also sometimes go above the king. So it might go 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. Okay, so that's the spades. So I'm just going to put those back. Now, the next one is the clubs. Okay, so here's the clubs going from ace at the bottom all the way up to king at the top. And so that little symbol there, that's called the clubs. Okay, so the spades and the clubs, they're both black cards. They're the 2 black suits. So half of the cards are black and half of the cards are red. The next suit is the hearts. And here they are here, going from ace at the bottom up to king at the top. And you can see why that one's called the hearts. And it makes sense that the hearts are red because we usually draw hearts as red or pink, don't we? And then the last suit is the diamonds. And it's easy to see why those are called diamonds because it's a diamond and it goes from ace at the bottom up to king at the top. But sometimes, as I said before, ace can go above the king. Okay, so we've got 52 cards in the deck of cards, and half of them are red and half of them are black. So if I shuffled all of these cards together randomly, and I'm not a very good shuffler, but if I did, and then I placed all the cards on a table so that we could only see this side of the card. And in a deck of cards, the reverse side of the card, which you're looking at now, they're always identical. So you can never tell what the card is from looking at it this way. So they're identical. One is an ace and one is a diamond. So if there's 52 cards in the deck and half of them are red, exactly half are red and exactly half are black, an easy probability question to start off with could be, well, if you pick a card at random, what's the probability of that card being black? Okay, now when we're doing probability, when we're working out a probability as a fraction, what we do, the bottom number of the fraction, which we call the denominator, we put the number of things that could happen. So if we pick a card at random, there's 52 possibilities because there's 52 cards in the deck of cards. Now the number we put at the top, which we call the numerator, that's like the chances of getting it right or the chances of winning a prize. So if I said there's a $50 prize if you randomly pick a red card from, no, I said black card before, so I'll say black card. So there's a $50 prize if you randomly pick a black card from the full deck of cards. And you can only see the cards like that. So the number we put at the top is the number of black cards that would be in the deck. Now we said that exactly half of the cards are black and half of the cards are red. So you can probably work out quite quickly what half of 52 is, okay? And it's 26. Now that makes sense because that 26, it includes 13 of the clubs and it includes 13 of the spades, okay? So remember that there's 13 cards that are clubs and 13 cards that are spades, and that's all of the black cards in the deck. So the probability of picking out a black card randomly is 26 over 52 because it's 13 clubs and 13 spades. But we know what we're talking about there is the chance of doing that is exactly half. Okay, because if we have a fraction which is 26 over 52, well, we know that that can be simplified. And one easy way of seeing that that can be simplified is that you've got an even number at the top and an even number at the bottom. Okay, so when we've got even numbers, well, at least we know that both of those numbers can be divided by 2 if they're even. So if you did that, you would then get 13 over 26. And then you would divide the top and the bottom by 13. So you would get 1 over 2, which is a half. Okay, but we already sort of knew that the probability was half because I said half of the cards in the deck are black and half of the cards are red. So that's quite an easy one, really. Okay, so let's do another one. So this time, the question is what is the probability of randomly picking out a number 5? Okay, so there's a 5, but it's not the only 5. Now, as you're watching this video, in your head, think how many 5s are in the deck of cards. Well, there's one for each suit. So there's a 5 of diamonds, there's a 5 of hearts, there's a 5 of clubs, and there's a 5 of spades. Okay, so there's one for each suit, and there's no more. So here are all the 5s which are in a deck of cards, and as we can see, there's 4 of them. And so if the question was, well, what's the probability of randomly drawing out a 5 from a deck of cards? Well, there's 52 possible results because there's 52 cards that we could randomly pick up or randomly draw. But only 4 of those are like the winning possibilities, or the possibilities that we're interested in, or the possibilities that had a prize. So we have a fraction here, which is the probability, which is 4 over 52. And when we look at that, we can see, well, that's a fraction that can be simplified as well. And we know it can be simplified. Well, one reason we know it can be simplified is that it's an even number at the top and an even number at the bottom. So let's just say that we did that. Okay, if you take this 4 and you halve it, okay, which is the same as dividing it by 2. That 4 becomes a 2. Whatever you do to the top number, you have to do to the bottom number. So this 52, well, if you halve it or divide it by 2, that 52 becomes 26. So we now have a fraction which is 2 over 26. Okay, but that can also be simplified. Okay, if we halve that 2, we get 1. And if we halve that 26, we get 13. Now you could do that without the middle step. I'll show you. So remember that the first fraction we had, which is the probability, was 4 over 52. Okay, if you just skip the middle step, you might be able to see that you can get that 4 to become a 1 by dividing it by 4. And whatever you do to the top, you've got to do to the bottom number as well. So when you divide 52 by 4, you get 13. So the probability of randomly picking a 5 from a full deck of cards is 4 over 52, which is the same as 1 over 13, which we can say is 1/13. Okay, here's Toby helping me with the probability lesson today. He's walking all over the playing cards at the moment, and he's just knocked some of them on the floor as well. Okay, now the next step with this is, okay, so the probability is 1 over 13, but we might want to know how we can express that probability as a decimal or as a percentage. So what I'm going to do now is I'm going to get the calculator on my phone. Okay, and remember that when you want to turn, let's have a look at what we've got. When you want to turn a fraction into a decimal, we'll turn it into a decimal first. All you've got to do is get your calculator and do the top number divided by the bottom number. Okay, Toby's saying goodbye because he's being a bad cat. Bye, Toby. So here's what we're going to do. We're going to get our calculator. We're going to do 1 divided by 13, and we get an answer there. I can't read that without turning my phone around, so I'm going to have a look at it. And we can see that the answer is 0.07692307692. But when we're writing down the answer as a decimal, what we can do is we can write the answer to maybe 2 decimal places or 3 decimal places. So I'll show you how to do that. So on the paper now, I'm going to write down the answer that we got. Okay, so when we did 1 divided by 13, we got this answer, 0.0769 blah, blah, blah. But to make it easier, I'm going to say, well, we can round that to 3 decimal places, all right? So when we round that to 3 decimal places, okay, we want a number which is going to be 0. something, 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 okay? And we're going to stop when we do 3 digits after the decimal point. Okay, so the first 2 digits, well, they can stay the same as they are. And the crucial thing here is to look at the 3rd digit up the top and see, well, do we keep it or do we round it up? So as you can see, the original decimal we got was 0.0769. Well, we don't want to keep that 6 because we can see that the number after that 6 is a 9. And because that's greater than 5, it means that we round that 6 up. So we round it up to 7. And so we can say that the probability of drawing the number 5 out of a deck of random cards is 1 over 13. And as a decimal, we can say that the probability is 0.00769. 0.077 rounded to 3 decimal places. And when we round something to 3 decimal places, what we should do with our answer is we should write 3dp after it, which means that we've rounded that to 3 decimal places. And that's telling us that this isn't the exact answer, okay? Because the exact answer is a long string of numbers that goes on forever. But we can make it really, really close by just rounding it to 3 decimal places, which makes it easier to understand and easier to write and to read. And so we can say that the probability is 0.077 to 3 decimal places. Now, there's one last thing that we can do. And the last thing that we can do is to do the probability as a percent. And the easy way to do that is to take the answer we got as a decimal and to multiply it by 100. Okay, so remember that the probability we got as a decimal was this number here, and we just went through the process of rounding that to 3 decimal places. So what I'm going to do now is do times 100, right? Then I'm going to press equals. And this gives us the answer now as a percentage. Okay, so the answer is, I can't read this backwards. So as a percentage, the probability is 7.692307 blah, blah, blah percent. But once again, we're going to round that. Okay. So if someone asked us what's the probability of drawing out a 5 from a deck of cards, and they said give us the answer as a percent. Okay, so we could say that the answer is 7.692307692331%. But once again, we want to round that to, let's round it to, how many places should we round that to? Let's round it to 3 decimal places again. Okay, so to round it to 3 decimal places, we want to make the answer 7 point something 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 percent. Okay, so let's have a look at what happens. Okay, so we're going to keep the 6 and the 9. And the really important thing here is, well, what happens to the digit after that? And the digit after that is a 2. And the digit after the 2 is a 3. And because that 3 is less than 5, we don't need to round the 2 up. So we're just going to keep the 2 this time. Okay, so the probability as a percent is 7.692%. And as I said before, we're going to put 3dp under that to show that it's to 3 decimal places. Okay. All right, so for those of you who were with me on the Zoom lesson last week, we did those sort of questions, but just with questions about picking different coloured marbles out of a bag. The good thing about doing these questions with the playing cards is that you can ask more interesting questions, because you can ask questions about the colours, about the suits, about the numbers, about the picture cards. So far we've done 2. The first one we did is what is the probability of picking out a black card at random, and we worked that out. It's exactly half. It's 1/2, which is 0.5, or it's 50% by the way, but we didn't work that out for that question. And then the question I've just been talking about for the last almost 10 minutes now is what is the chance of picking out a 5 at random? And we worked out that that's 4/52, which is the same as 1/13. And then we work those out as decimals and percentages. Okay, so that's the end of the video today. If you didn't fully understand the video, you can always play it again, and you can pause the video and you can write down the things that I'm talking about. Like when I hold these up, you can write them down yourself, and you can get your calculator out and do the same steps on your calculator and all of that. On the Google Classroom, I'm going to put the time and date of the next Zoom meeting. And in that Zoom meeting, we'll do some probability questions using playing cards. So if you've got your own playing cards, you should bring them to that Zoom meeting, but it doesn't matter if you don't, because I'll have my playing cards here. And we can do other Zoom questions, and people who are ready to can try and answer some of those questions that we do. Okay, I'll see you all soon. Try and start off the probability questions in the textbook, which is chapter 5, which we talked about in the Zoom lesson previously. So there's some reading, then there's exercise 5A, which I talked about in the Zoom lesson. Feeling confident with that, you can go on to exercise 5B, maybe 5C. I'll see how the progress of that is with everyone when I talk to you on Zoom. Okay, I'll see you soon. Bye-bye.